Okay, so let's start. Today I invited my colleague Hunt from 3D Print Cornwall to this conversation or to this call, and happy to have you here, Mike.
It's happy to be here.
Yeah, how is going in Cornwall?
Nice and sunny as usual. Um, Coming up to the time of year where everyone leaves Cornwall and vacates on their holidays back to their normal lives, so not as busy as usual.
Yeah. Today we will talk about Orca, the new fishy filament release with Filamentum, and uh, everybody is getting to know this filament, but you already know it for a few years, I can say probably. How did you came to this collaboration with Ion?
Yeah, so early on in our the 3D printing industry, for me, we were looking around for different materials. We saw how much plastic could potentially be used, so we seeked out a more sustainable alternative. Really close to me was Ian Faulkner from Fishing Filaments. Actually, the operations not too far down the road. So it's a great solution for a local recycled plastic. When I first met Ian, they were in the very early stages. So I think a couple of rolls had been produced, and it was very much still a hope. So we started collaborating to make it work. Yeah, from the very start, it was quite an important thing. Yeah.
I love how all your people around this fisher filament community, if I can say this way, are collaborating together. We already spoke with you a few times, and you also mentioned a lot of collaborations, and I like everybody's helping to each other, and this is really awesome because everybody should learn this from the world, I guess.
Yeah, that's right. So since we've taken on making things or products with it, or end use products, we've had a lot of interest in from other parties wanting to do the same. So we've helped quite a few companies over the period of time get used to printing with the materials and helping them succeed. Yeah. So we've had some great success with it. Yeah.
That's true. And the Orca, we just released it, and you already printed. Uh, do you think it is possible to uh, have maybe like do you think there is other filament in the world comparable with Orca?
Well, so if you look at the whole thing about the fishing fleet comes from a recycled fishing net. So there's a lot of materials out there today which come from an industry source which hasn't been used, and there's a post-industrial and a pre-industrial sort of waste. Um, the best thing about the fishing net is this stuff's been used. So we're using a carbon fiber which comes from a recycled source which I believe is the only type of its in the world. And actually, PACF is a huge part of our business. There's end use products that we produce every day in PACF because we know the endurance that they can sustain. So um, it's a very important thing actually, and there's a lot of uses for Orca in various industries, and I think just showing people or helping people guide people to a roadmap for success for them is relatively easy when you consider the CO2 saving for using a recycled carbon fiber rather than a virgin material. So
Yeah. You are running your own 3D printing business. Uh, how do you usually persuade people to try something new? Like, because this is not typical to use recycled plastic, recycled. Are they trusting these products?
yeah, so we work with customers that initially come to us with an idea. Usually, because we know the material so well, we'll shape that idea around what we know the material can and can't do. So just like FDM printing, there is other types of 3D printing where certain things in FDM are easier. So we work with our clients to adapt their designs to be more suitable for the material as well. So it's about working with the client about their design, showing them that an alternative plastic exists. Um, a lot of our clients that we have are local. So the fact that we use a locally sourced recycled plastic is extremely important to them. We're in a tourist industry down in Cornwall, so we have a lot of people visiting Cornwall looking for souvenirs and gifts to take away. So we have local clients taking advantage of the tourism industry in Cornwall to export waste from Cornwall, and then we have our sort of large clients like Soho who sell in places like Selfridges and in online markets to a retail environment. So which again is exporting waste. So I think it's extremely important. Yeah.
I would just add that Soho is a company, Soho Lighting, and they're producing the beautiful lampshades. You can find it also as soon as a case study at our website. And like, what do you think are the use cases like the best for this material? Like, who should be interested to take a look on Orca?
Okay, so if you have a current existing lineup of using a carbon fiber material, then it makes sense on in various sort of levels. But in the most efficient level is the CO2 reduction. So if you're looking at using a virgin material versus using a recycled orca material, carbon fiber material, then there's that initial CO2 reduction in using a recycled material virgin and using a virgin material. It has the same aesthetics as carbon fiber nylon does across the range. So if you're looking for a sort of a like-for-like product, which actually can add sustainability into the business in terms of a reduction in CO2 over a period of years. We just had another company, Graph Marine, which I do think we're releasing another case study with, where now we're using Orca inside their sort of coastal marine products, electrical items. That they've actually hit figures because of the alternative source they were using before. We were buying in parts from China. Now we're producing them in the UK using a recycled material from Cornwall. So again, it's the exporting of waste value as well. So we're reducing CO2. We're now exporting waste from the UK in terms of monetary value for parts sold, and also clearing up, helping to reduce the burden of recycled fishing net in the UK.
Yeah, awesome. And we already know note about the Soho lighting. Do you have also other customers you can talk about who you persuade to use this sustainable material for their products?
Yeah, so recently we Playerverse, so I think we're also doing a case study with them. So we needed we currently produce their items, or used to produce their items in a recycled PETG. Actually, it wasn't locally sourced. It was UK sourced, but it wasn't locally sourced. So we wanted to switch to a more local material. In actual fact, we had a few breakages of the product. So over the period of years that they were installed, or period of time that they were tested, we had a few breakages. So we needed something to endure the kids' play areas a little bit more. I think kids can be quite boisterous at times. So producing things for a kid environment or inside an environment like that, it had to be fairly robust. So we recently, since the launch of the Walker, we switched all production from PETG to PACF for the button bases, for the bash bases for the back of these things. And since then, we've had zero issues with breakages. And as well as inside the button system, there's a little computer which gets hot. So as well as the strength resistance, we've also got heat resistance inside there as well. So it's added benefits to already required materials.
That's amazing. That's amazing. Definitely. If you can reduce also the leftovers and everything, it's really helpful. And if you find out that material what can work better as the one you do, it's amazing. I'm really happy to hear that.
Yeah, I think it's about finding multiple values in which the material can benefit you. I think with the heat resistance, the chemical resistance, and the endurance of carbon fiber nylon, then you can make lots of fairly end-use products for lots of customers.
And is it easy to print with Orca?
Okay, so you need enclosures. So just like with any sort of nylon, you're going to need an enclosure. You'll have varied levels of success from printing inside a heated enclosure as to printed inside a non-heated enclosure. So there's various levels of success. You can use brims and things like that to help to anchor your part down. There is shrinkage in any sort of carbon fiber sort of part, so keeping it on the build bed can be particularly difficult, but if you use the right glues and if you use the right build sheets on all the printers that we use, then you will find success. We've made profiles for the printers that we use on the farm here ourselves, which includes Trilab, Bamboo. Um, we're working on some Epsilon profiles, but we're looking forward to the next generation of machines to make profiles for. In terms of speed, printing very quickly as well when with the material as well, so it's able to use the next generation of printers quite well.
Awesome. And I think the most important to mention while talking about printing with Orca, which is recycled nylon from fishing nets with recycled carbon, is it very important to mention the drying. What are your experiences with drying and what works for you?
Yeah, so carbon fiber nylon is hygroscopic. So we all know we've all dealt with various hygroscopic materials as 3D printing engineers before, but we're not really at all phased by this anymore. There's certain things on the market which enable you to benefit from the drying techniques. We have used certain dryers for the material, and they work very well. First of all, we use an APM F300, which we do have in stock, sort of in the UK, which we do use. We have it for our clients when they're looking to sort of take 3D printing on board. So we'll sort of, that's a big important part of us as pre-drying the materials is extremely important. The prior preparation of nylon is just as important as any other nylon or carbon fiber. So drying at 80 degrees, we found for 12 to 24 hours prior to printing has been fantastic. And printing from the dryer also as well.
So, like the full enclosure of the system is the best way to how to handle it.
Yes. So yeah, enclose the filament, heat the filament, and print from the enclosure that you're heating from. However, it be the APM is a great start for if you're drying 3 or 4 rolls at a time. If you have like a smaller device like a Sunlu V2, you can able to get up to about 70 degrees. It may take a little bit longer to dry. Thing is, with the hygroscopic materials, you have to get the temperature up there to draw the moisture out of the material. So sometimes 70 degrees is a bit on the borderline. I'd like to see sort of 80 degrees.
A lot of
Uh,
people are using also silica gel boxes. It will be helpful in this case.
Prevention, yeah, it's not going to extract that unless you get the material hot. You're not going to extract any moisture out of it. Okay, so the first step is to heat it up. You can put silica gel or sacs in there. Once the moisture is released from the material, it has to go somewhere. So if you have silica gel sacs or anything like that, it's got to go somewhere. So that's the best place for it to go. But not on their own.
So
You won't find any success just using the sacs on their own. It would need to be accompanied with a drying system.
yeah. So probably also this dryer for fruits or oven in our kitchens. What do you think about it?
If you can get it up to 70 degrees, like I said, between 70 and 80 degrees is that sweet spot in which you can extract moisture out of nylon, or especially this material.
Yeah.
If you can get it up to those temperatures and those stable temperatures without melting your spool, the spools are polycarbonate. As far as you can edit that out if that's wrong. As far as I can see, we're good to up to 90 to 100 degrees on the spools that you guys are using. So that's been great for me. To have a spool pull out the oven, which is all wonky, it's not the best thing for you to have as an engineer. So
All right, all right. And you noticed also the high-speed printing. Are there any limits? What people should think about while printing? About maybe some sizes of those printing parts or something?
yeah, so I mean, there is generally quite we're meeting physics sort of things with most printers. Most printers can go only up to a certain temperature.
What does it mean, please?
So the temperature of a 3D printer or a nozzle that extrudes the plastic can vary between different manufacturers. And most 3D printers that are on the market or budget level market or an industrial level market can go up to about 300 degrees. And some printers a lot more, but most printers that people use about 300 degrees. This will limit the speed in which we can print, right? So when we're melting plastic and we're printing quicker, then we're going to increase the speed, increase the temperature so that we can increase the speed. if you have a limit on your speed, let's say 300 degrees, then that gives a limit to your speed. So we've generally found between 250 and 300 millimeters per second to be our sort of limit with Orca. So there is a limitation there. There is certain machines. I think Bamboo may have released or announced another machine recently, which has an upgraded temperature on there, and it's a sign of the industry learning exactly what we've all known for years, is that if you want to increase the speed, if you want to increase the technology, you need to print hotter. You know, you can only melt plastic so quick. There's the sort of nozzles and the thermistors and the stats that we're using can only heat metal so quickly, and keep that metal hot.
You also mentioned the nozzles. It is containing carbon, 10% of the weight of the filament. So definitely hardened or something like full metal.
Yeah, so we're talking about hardened nozzles. Any sort of brass nozzle will wear away very quickly. A stainless steel nozzle will benefit you greatly, and there are other nozzles that will last maybe a bit longer than a stainless steel nozzle by various people out there. So have a look out for them. In terms of nozzle size, we found no issue using 0.4. A lot of filament manufacturers actually worry about introducing people to 0.4 mil nozzles on a carbon fiber.
Yes, we too. We agree that we should definitely like call to people to use 006.
Yeah, I mean,
It's the
it's very,
safe way.
yeah, as aeropoor as possible. You just have to sort of reduce the flow rate down a little bit, and that again, that's again because you're trying to print faster. Okay, so if you're trying to print faster and the temperature's not there, then there is a limit that you're going to hit there. And 0.6 is great. You will obviously get a slightly less detail on your products, but you know 0.6 can be a lot quicker. So there is benefits to just using a bigger nozzle. Isn't just losing definition. We've also got some speed to reduce some hours on your current existing parts. You can print them quicker. So yeah, it's not a bad thing at all.
All right. And after the printing, I guess because of the shrinkage, you should keep the print on the build plate and just let it cool down slowly, I guess.
Yeah, so the print needs time to sort of regulate. For sort of large prints, if you're like on a sort of bamboo or something like that, then if you're printing like sort of large diameter parts, then sometimes it's actually best to keep the build bed sort of flat on a surface with some weight on it. It's going to try and pull your build bed off the magnets, and the heat that's inside on your build bed still will help encourage that part to warp. So sometimes actually on bigger parts it's a little bit better to get out quick straight away. For smaller parts it's better to leave it regulate.
All right. And what about the post-processing? Did you ever glue any two parts made of Orca together?
So no. So far we've only really used sort of fixing points. So parts that we've made fixing points for us to bolt together. And in terms of gluing adhesive, we sort of haven't really used or fixed anything together in terms of a gluing capacity. Because of carbon fiber being what it is, we're looking at chemical resistance, we're looking at heat resistance, and we're looking at things like that, most of which would upset a glue. So if you're looking at sort of parts together, then there's various methods out there in which you can join and bolt parts together using screws and embedded threads. So I'd say if you're looking at down that line, then maybe perhaps more down that route, because of if we're using carbon fiber, it's in a place where we want chemical resistance, not to add chemicals in to be a weak point in the system. So yeah, I'd definitely look at using more engineered sort of aspects to bolting things together.
That's reasonable. That's reasonable. And what about any other kind of post-processing, like sanding or anything else? Do you have any experiences with these, or is it even like necessary?
Yeah, no, not really. So the layer quality for carbon fiber is the same as most other carbon fibers. I think anyone that's used carbon fiber nylon for 3D printing is aware that you can lose a lot of layer lines when you're printing it. due to the nature of the material and the way it's printed without fans. So you can lose a lot of the ley lines. Post process isn't typical. However, there is, and we have done some work with AMT on post processing the fishy filament line and the Orca line, and had absolutely fantastic results. So there are post processing techniques available for carbon fiber, and in the line of the AMT system, which I'm sure you guys can share some details about with
Yeah,
this detail. But yeah, it's an extremely good way of smoothing carbon fiber parts and more tough parts.
we should definitely make a case study about this one because it's very interesting. I saw already some pictures and I was very surprised. It looks like if you're smoothing ABS with some fumes. So I was very, very surprised with the result.
We did some trials with the Soho shades. Some of the trials that we did are on tour with AMT when they go around to various shows. So some people may have already seen them, but actually if you thought you could see a ley line before, you soon realise that you were completely wrong, and it kind of the part turns into an injection molded quality part. So whether it be Orca or the fishy filament. So actually, it's an incredibly important process. There is a cost involved, just like anything that we do actually. But what if you talk with your customer, and we've had this on various occasions, the per unit cost is quite reasonable if you do a larger quantity. So like anything, the larger quantity is going to give you a better price. However, getting your customer up to that stage can be quite difficult. So
And overall, what do you think about Orca? It is it the future?
in terms of recycled material, so there hasn't been anything else on the market quite like Orca before now. Everyone in this industry used PA6, and I think a lot of people are using it for end use parts. Some of which engineers like me, we can't talk about everything we do. A lot of stuff is under NDA, but most people will tell you they're using a lot of carbon fiber nylon, and most of it's for end use parts. If we can look at the CO2 reduction from using virgin to Orca, if we looked at if we convinced half the industry to try it, it would be a vast number in terms of CO2 reduction. So I think it's a community thing. As a community, we can choose more sustainable products, and as a community, we also very aware of people that are using plastics, which are at the end waste of a injection molded line, right, and then used as recycled material. We all know that's not recycled material. That's just the leftovers from an injection molded line. Actually using the recycled material that comes from products that we've used, discarded, and goes back through the system is incredibly important. And I think as a 3D printing community, we really should be calling out some of these people that are making recycled materials from unethical sources, or sources that are deemed recyclable for their benefit. So I think that filaments like fishy filament and filaments like Orca, and the non-oiling that you guys do, I mean, there's a certain responsibility behind sustainable material, not just taking advantage of a situation and calling your material recycled, or flying it all the way around the world with no point, or look at where it's coming from and its sustainability, CO2 output. So there's a big thing there from the community to support materials like this, to help encourage others to be more to privatize recycling. I mean, there's lots of various sort of companies we're working with right now, just like fishing filaments, to make sources of material which are more geographically better for the locations we're printing in. Just like Nestle got in trouble shipping water around the world, we can't be seen to be doing the exact same thing with plastic, and actually making it more sustainable is a global thing, not just a local thing.
I think it's all the time something which can be done better, in my opinion, and there is always a place and possibilities how to make things much more efficient. I'm sorry,
Yeah, yeah.
and I hope this is also something for us to think about every day, because the one thing is to recycle something, and the other one is the responsibility also of the CO2 production. So every time having also this in our own mind is not the easiest task to do, but
And it,
hopefully working on that.
yeah, and as engineers, it's generally harder to print recycled materials. So yeah, there's a challenge, but most 3D printing people won't shy away from a challenge. If they're told they can't do something, they're quite happily proven wrong. So I think yeah, from that point of aspect, I think the community's sort of ready for a challenge, which is great. So
Yeah, and also sometimes the price decides, how it is
yeah, I mean, if you
for
look at
most of the end users. I think, yeah.
yeah, absolutely. If we look at sort of the price, though, I mean, the way we look at price is we work with when you're dealing with a procurement company, which a lot of the time we are. When we're selling to various businesses, we're looking at procurement departments. Procurement departments don't really look into the sustainability of an item. Okay. So perhaps when mentioning to the person you're quoting up to inside that organization, that perhaps they should speak to the environmental manager of the business to show that the item they are about to procure may cost a few pence more per item, but actually, in terms of where the business is going as a whole, and the sustainability drive for the company, it actually gives other people inside that business a lot more responsibility with the product. So, not only have you just ticked the box for the procurement manager, but you also tick the box for the sustainability manager, for the manager in charge of reducing the CO2 output for their business. And he would love to know about that item that the procurement guy is about to buy, which, as a procurement team, I come from procurement, so I can answer this quite well. The procurement team doesn't really care about where the product's coming from, its background, what it's done, or the journey it's taken for him to buy that product. He cares about the price, and that's his job to care about the price. That's his job. That's what he's employed to do. But actually, beside him are the right sort of people that you want to talk to, the sustainability managers, those sorts of people, and they will talk to you. I mean, obviously, the success we've had with the materials we do is by looking into companies and looking past that procurement manager and really engaging with the way that businesses selecting where their manufacturing's done. During COVID, we had a massive crisis where everyone's manufacturing chains changed overnight. Suddenly, that their tool that was in an injection molding factory in China, they couldn't use anymore. So they had to find more local manufacturing solutions for their business. If you can couple that with using a sustainable material, then what it does, it encourages privatization of recycling. And we talk about this quite often. To encourage privatization of recycling is to encourage investors to want to recycle something for a return on investment. Okay, and the whole world works in that way. And if you want to recycle something, it's going to cost money. Having the right output and the valued output markets, like we do with some of our clients, helps us elevate that cost of the material and thus pay for the recycling process. So it's extremely important as a whole to back organizations that are using waste, and I'm talking real waste, to make filament with, because we're only going to make more waste, and we're only going to use that waste. And if we keep pretending injection molding leftovers from injection molding lines is waste, then we're not going to go anywhere. So I think that's
In my opinion, that's upcycling, not recycling.
I think I could rebrand about 5 businesses rebranding on their website overnight, because it's if someone was to regulate that, actually it's not recycling. It's because
like it's still good. It's still good. They're using every resources, but can be better.
Of course, it can always be better. So yeah, it's I think it's just important to pay attention to.
That's true. Thank you for your opinion and your experiences. Is there something you would love to tell everybody who is watching this?
So yeah, no, I'd love to for anyone watching this to reach out to any of the customers that we have, and you'll see, you'll see a few of them, Filamentum are releasing some of our clients' work, is to really reach out to them to see how it may change their business, and it changed the way that they operate inside the industry that they do. And every single one of them will tell them that it's had a positive impact on their business. Being able to offer a sustainable material to their clients is something that they've always wanted to do, and helping them enable that as a 3D printing business has been hugely important to me over the last couple of years. And being able to help it get to the point where it's globally available for now everyone to use and not just me, is extremely important. Right? I can't print everything forever. We're here to help people in any way if they want to use this material. So yeah, just reach out. I'm fairly approachable on social media and on via our website. So just reach out if you need any assistance. It's not a problem at all. We also keep the material in stock here in the UK. We keep a few materials that we use on the print farm here for stock, so that anyone's more than welcome to reach out if they want a sample or try some. It's not a problem at all.
Thank you very much. Thank you very much for everything, for your opinions and all your experiences. And it was a pleasure to meet you again. And I hope it is amazing weather in Cornwall and you will enjoy the rest of your day.
Yeah, thank you very much. Have a good day.
See you.